Hey Math 1. Just to help you guys out with preparation for that take-home quiz that you guys are going to be doing here as soon as I post it, I thought I'd do the odd-numbered solutions for this quiz review. Now there's only 6 of them, so we're going to do 1, 3, and 5 on this video. Hopefully that will give you guys just a little more of an advantage and edge going into tomorrow's quiz. So, you know what? This is going to look structurally a lot like the quiz you're taking tomorrow. I'm going to give you guys a chart of values. I'm going to ask you to define your variables, create a set of ordered pairs from the data. Don't graph it. Just things like that. So, first things first, defining the variables. So, to know which one's the x and the y is pretty much a matter of knowing which one's independent versus dependent. Independent x is almost always going to be time when time is given. Time, x. So time is going to be the x value, and what you would say is in months. For the y value, you're going to say CD sales in hundreds of millions. It's that easy. Now, what would a set of ordered pairs look like for this? Well, an ordered pair is x comma y. But you know what? I don't know if we were to graph this, I don't think you're going to want to graph 1,996 on the x-axis. So one way of getting around that is to say, instead of just time in months, you can say time in months. Actually, this is a typo. It should be years. My apologies. Time in years, and what we can do is we can make year 0, sort of like our starting point, 1996. So time in years since 1996 AD. And what you can do then is say, this is 0 years from 1996, this is 3 years from 1996, this is 4, this is 8, this is 11. All I'm doing is subtracting 1996 from each of these. Now, I don't believe I put that on the quiz where you have to make that adjustment right here, but just for future reference, if you do have a chart like that, it's way better to say that this is 0, comma 4.49 instead of 1996, comma 4.49. So here are your ordered pairs. 3, 6.48, 4, 7.03, and I'll just write out the rest. Now, how would you guys find the rate of change from the beginning of the data set to the end of the data set? Well, if we want to do that, the only thing we really need is the first data point, which is 0, 4.49. And the last data point, which is 15, 2.24. Everything else doesn't really matter because we're just finding the entire data set's rate of change. Now there's a formula for rate of change. It's the same as the slope formula. That formula is, if we have our 2x coordinates and our 2y coordinates, the rate of change is you take the y2 minus y1 over x2 minus x1. So The difference between 2.24 and 4.49 is going to be negative 2.25. And then you get 15 on the bottom. Actually, no, it's 2.25. All right. So let's make sure we understand what these units actually mean. These units mean it's negative 2.25 $100 million, because that's what our y coordinate represented. So I'm going to put the dollar sign here and then 100 million. Wow. And on the bottom, it's going to be over the course of 15 years. And again, you guys should be able to reduce this fraction if need be, but for the purposes of this assignment, the fact that we're on remote learning, that's okay. So number 1 in the books. Number 2. This is where we had to graph one of those linear models where we're given a starting point and a rate of change. So an airplane 600 meters above the ground, that looks like a pretty blatant starting point to me. So I'm going to put that right over here. Starts at 600 meters. Yeah? And it begins descending towards the ground at a rate of 50 meters every 3 seconds. This was pretty straightforward. Rate of change. I always like to write it as a fraction to remind ourselves that it should be a fraction. Descending means that 600 meters is getting lesser and lesser and lesser. Negative 50 over 3. Yeah. So it's just asking us to graph the height of the hot air balloon. So the first thing I'm going to do is make sure I take my axes, the x-axis, x-axis and the y-axis, and just label them. Let's say what's going on here. Your x represents the horizontal axis right here. This is going to be time in seconds. And who knows, I may skip count. I'm not deciding that just yet. And then this is going to be the height of the balloon. In meters. So it's important that we have seconds for the x-axis and meters for the y-axis. Sorry, you guys can't see this whole picture, can you? My apologies. There we go. So the question is, if we have a starting point that's all the way up at 600 and we're dropping 50 units, the question is, what should we make each of these blocks a unit rate? We're going to have to skip count. Well, if we go by 50s, there's two 50s and 100 times 6 for 600. If I go up by 50s, then all I got to do is go up 12 blocks to get to our starting point. So I'm going to go by 50 meter increments here. So 50, 100, and maybe even every other one now I can just label as this one's 200, 250, 300, 350, 400, 450, 500, 550, and then 600. You must plot your first point on the y-axis. Some of you guys are not doing that. That's going to be a problem for the quiz tomorrow. Place your point right there. That's my starting point. It starts at 600 meters. On the y-axis, I'm plotting a point 600 meters. Now, down here, I think I'm just going to go by ones. All right, 1 second, 2 second, 3 seconds. So, one block vertically represents 50 meters. One block horizontally represents 1 second. So down 50, right 1, 2, 3. There's my next point. Okay? Then down 50, right 1, 2, 3 gives me my next point after that. Down 50, 1, 2, 3. Down 50, 1, 2, 3. Down 50 units, 1, 2, 3 seconds. Down 50, 1, 2, 3. You guys get the idea, yeah? At this point, I think I have enough points to plot a pretty accurate linear equation. And then it will just keep going forever that way. Or at least till we get to the x-axis. At that point, the balloon would be on the ground. Okay, number 1 done, number 3 done. Let's see what number 5 holds for us. This is the one where we have to write the equation of things. So you know what? I'm just going to use this as a reference point. On number 3, if you were asked to write the equation of that line, remember y equals the starting point plus if it increases, minus if it decreases, the rate of change, and then you just multiply that by x. So this is our basic prototype, our formula that you plug into to get the equation of a line. So the equation of the line we graphed would have been y equals 600 minus, because it's going down, 50 over 3x. That would be the equation for number 3. So let's check out what number 5 looks like. A standard bathtub currently has 16 gallons of water in it. Looks like there's our starting point. When filling the bathtub, the spout releases an average of 2 gallons every 40 seconds into the tub. So our rate of change is equal to 2 gallons divided by 40 seconds. Gallons per second, okay? And since the spout is releasing water into the tub, it's filling the tub up, so it's going to be plus. Now, I'm also noticing that 2 over 40 can be simplified, so I'm going to do that right away. 2 over 40 is the same as 1 over 20. So I got the 2 pieces of info needed to write the equation of the line. Y equals starting point, 16, increase plus 1 over 20 times x. And we talked about how to define your variables. X represents usually time. Time is given here, seconds. And it's really the time in which we're filling up the bathtub. Y represents the volume of the bathtub, how much water is in the bathtub. Amount of water in the bathtub. And the unit we're using for that is gallons. So, I mean, if you can do this, that's an automatic 3 points right off the bat. Now, in each subsequent question, each one after it, you are using that equation based on the information given to you. Determine how much water is in the tub after 3 minutes. So they're either giving you an x value or a y value. In this case, time represents x. Gallons, so seconds are x. Gallons are y. They're giving us a time value, but they're giving it to us in terms of minutes. So we got to convert it to seconds. So there's 60 seconds per minute. So we're talking about how much water's in the tub after 180 seconds. So what I'm doing is I'm taking my equation and I am replacing the x with 180. Now, how do you multiply a fraction times a whole number? Put the whole number over 1. See if you can cross cancel. I instantly see there's a 0 on the top and a 0 on the diagonal. Divide by 10, you get 18 times 1 over 2. Well, 18 over 2 is 9, so it's going to be 16 plus 9, which is 25. So the answer to part B is y equals 25, the unit. Y represents gallons. So make sure you put the unit there to receive full credit. This tells me you know exactly what you're talking about, and you're not just somebody who's like changing numbers and letters and giving me just an answer at the end that doesn't make any sense. This makes sense. Gallons of water. Okay. Part B is done. Part C. So I'm going to erase everything we did for part B. But I'm keeping my equation and the variables defined because that's going to help me out to solve this one. If the bathtub can only hold a max of 40 gallons of water, determine how long it would take for the bathtub to overflow with water. So how long is it going to take for the bathtub to reach its max capacity of 40 gallons? Well, what they're saying is the y value in the equation is now being forced to equal 40. Gallons of water is the y value. So instead of y equals 16 plus 120x, I'm going to go 40 in place of the y equals 16 plus 1/20th x. And then when you solve that equation, you are determining what x is. X represents a time value. How long? That's a time value. So I'm going to subtract the 16 from both sides. 40 minus 16 is 24. And you got 1/20th x. Now there's a couple different ways to solve this. You can find a common denominator, or you could recognize that, hey, if I multiply by 20 over 1 on both sides, that's going to completely get rid of the number in front of x, which is what we want. And in reality, 20 over 1 is the same as 20. 20 times 24 is a pretty easy computation. 0, 8, 4. X equals 480. And we're talking seconds. And that's the same as 8 minutes. Probably 8 minutes would be the better way of describing that to another person if they really wanted to say, like, okay, how long is it going to take for this bathtub to overflow? You probably wouldn't get somebody who says 480 seconds. They're probably going to say 8 minutes. So, but we're almost at 19 minutes for this video, so you guys got your answers for the odds. Hey, work hard to get these evens to look as good as they possibly can. And you're free to use your notes or any videos that I've posted to work your way through this quiz that we're having. Thanks for watching. Good luck.